I think Max would do it too, smart ass. Dylan, that hurts, okay? I love my Mac. No. Stop it. Quit picking on me. Derivative of a function. Sure, you can call it 2.5 if you want to laugh at me. Definition of the derivative. Okay, instead of calling it m, I'm going to call it f, and then I'm going to put a little tick next to the f, like that. Little apostrophe, f apostrophe, like I'm going to say that. F prime of x, or the derivative of f of x, is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Anybody have an incredible sense of deja vu? No? I've never seen this formula before. What the heck are you talking about? So, we have a new verb in our class. The verb is differentiate. That means to find the derivative. So we can conjugate the verb. I differentiate. You differentiate. We differentiate. Il differentiation. Vous differentiate. I don't know. Let's stop. Anyways, so differentiate to find the derivative. Okay, so find the derivative. So we write it as, I know it's awful. Limit. You better be laughing at with me, not at me. And whatever. Anyways. Yeah, no more M's. M's are for losers. Okay, get rid of your brackets. Now, this is the part where you really love learning about Chapter 6 in Math 12. Because who really wants to FOIL x plus h cubed? Okay. As I look around the room, I have no takers. Yay, no takers. 1x cubed plus... It's 1, yeah, 0, 1, 2, 3. I just go 1, 3, 3, 1, and I just look for the second number to be a 3. So 1, 3, 3, 1. So 1x cubed, h to the 0, plus 3x squared h to the 1, plus 3x h squared, plus 1x to the 0, h to the 3. Yay, foiling. X minus x cubed all over h. So I just grabbed Pascal's triangle for those people that have forgotten from Math 12. 1, 3, 3, 1 is the fourth row of Pascal's triangle, and the powers of x's go 3, 2, 1, 0, and the powers of h's go 0, 1, 2, 3. We clean it up a little bit. Oh. So you get x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed all over h. Now, you could jump from this line down to this line. I put that middle line in there as a teaching line. Okay? X cubes cancel. Hey, look, Mr. Epp, let's factor in h. Are we always going to have to factor in h? Yes. Well, most of the time. For you guys, yes. 3x squared plus 3xh plus h squared all over h. Hey, look, Mr. App, the h's cancel. That's super. You're right, it is. Can we put 0 in for h now? Yeah. 3x squared plus 3x times 0 plus 0 squared. Hey, Mr. App, that's 3x squared. So if our original function was x cubed, our derivative is 3x squared. Derivative is slope. Slope anywhere you want on the curve. So if I said x was 2, we would know our y-coordinate is 8, and our slope is 12. Cool? I'm getting a strange look. What did I just do? I just substitute 2 in for x, I get a y value. If I substitute 2 in for x into the derivative, it tells me the slope there. You betcha. They are synonyms. Yeah. Alternate definition of the derivative. The one that I don't use very much. F prime of x equals, and I have to look it up because I don't use it very much at all. Where is it? Yeah, it's that x minus a business. F prime of a equals the limit as x approaches a of f of x minus f of a all over x minus a. You know what, I don't want to. Anyways. I'm not a big fan of it because it doesn't really do much for me. Okay. So differentiate the square root of x using the definition. I'm not going to use the alternate definition. I'm never going to make you use the alternate definition. No, you just have to be able to do one or the other. So you have to be able to find the derivative. There's a lot of, I haven't found the formula sheet yet, so I should go and start looking for it, but I get the feeling that you have to, this is going to test your memory skills in terms of what you have to remember. So what I need to do is the limit, make a table, no. F prime of x equals the limit, h goes to 0, of root of x plus h minus root of x all over h. Mr. App, there's no way that I can ever cancel the x's or the h's here. So we need to do something. This is the part where it drives kids up the wall, because usually you rationalize the denominator when you're working with square roots. We're going to rationalize the numerator. So you're going to multiply top and bottom of the fraction by root x plus h plus root x plus h plus root x. Seems counterintuitive to do that, but that's actually the only thing you can do to remove the square root problem from the place that you don't want it. So root x plus h times root x plus h, x plus h. Root x plus h times root x, root x plus h times root x, minus root x plus h times root x, minus x, all over h times root. So I rationalized, I multiplied, I only multiplied out the numerator because that's where the problem was. I did not multiply out the denominator because I didn't want to make it harder. What happens to the middle terms? They cancel. So you're left with So I would call the middle line the teaching line again. I don't need to put it there. I could go from the first line down to the third line. Yeah? Now what happens to the x's? Cancel. What can you do with the h's then? Don't get ahead of yourself though. You're canceling addition and then you're canceling multiplication. What happens to the h's? They cancel. And you're left with, can you put 0 in for h now into the bottom? Yep. So you're left with 1 over root x plus 0 plus root x. Over 2 root x. Yeah? Okay, I want to hit the pause button. I don't want you to write anything down. I just want you to sit back and we're going to consolidate what we've been talking about. For the last hour, all we've done is the slope is the limit as h goes to 0 of x plus h minus f of x all over h. And then all I did, I called that 2.4. 3.1, I called it this. Is it the same thing? Yeah. What might start to blow your mind away is nobody's smiled and well, some of you have smiled and maybe started to recognize a pattern. We started with a function, x squared. We did its derivative. I called it 2x. A couple of seconds ago, we started with x cubed. We took its derivative, and we got 3x squared. Just now, we did the square root of x. People, last time I checked, square root of x can be written as x to the 1/2 power. You're thinking to yourself, why is he doing that? Well, maybe there's a reason for that. And then we just saw that the derivative was 1 over 2 root x. And we could write that as 1 over 2 times x to the negative 1/2. Mr. Rat. Anybody seeing a pattern? Maybe I'll put a 1 here. Anybody want to propose a pattern? And welcome to the power rule, folks. Dun dun. No. Welcome. Okay, so if I say find the derivative, then you can do that. If I say find the derivative using the definition of the derivative, then you got to go old school. Okay? Sorry, kiddo, but I will make you do a definition of the derivative question. Okay? Is it that bad? No. Pardon me? You know the answer too. Yeah, well actually I'll just say show that the derivative of this is this, using the definition of the derivative. Right? Lucas. It can actually be any rational. Then we'll have to learn a new rule. I'm going to add, so basically chapter 3 is starting with the definition of the derivative, the f prime of x equals the limit as x goes to 0. And then I'm going to start adding rules. We're going to learn about the power rule, which is what I just kind of scribbled on the page, powers. We're going to learn about the product rule, multiplication. We're going to learn about the quotient rule, division. And we're going to learn about the chain rule. The chain rule is composition, so functions within functions. And then I'm going to start to do trig rules and log rules for derivatives. And so chapter 3 is, might as well just call it rules. Okay? And then chapter 4 is going to be, so you've learned all these rules. I'm going to give you a problem. We're going to ask you to apply those rules to solve some pretty funky problems. Okay? So chapter 3 is rules, 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 rules. Okay? Okay. Where are we at? Does that kind of make sense what's happening now? Or it's chapter 3, Mr. Epp. It's kind of just washing over me right now. Okay, kind of just washing over me. Okay. What did I miss over on the side? Oh, so there's a whole bunch of different ways of writing derivatives. And it actually depends on what course you're in and who's your teacher and what textbook you're using. But this is one way of writing the derivative. We say y equals f prime of x. I've seen it written like this, y prime. So this is Newton's notation, I think. I should check and make sure. But anyways. The other more common one that you'll see is dy over dx. Guess what the d stands for? Derivative. It's the derivative of y with respect to x. So if I wanted to do the second derivative up here, I would go y equals f double prime of x. That's the second derivative. 2 tick marks. Woo. It's the slope of the slope. No, slope of slope is called curvature. Physics people, the first derivative is velocity, the second derivative is acceleration. Okay. So we could write it as y double prime. We could also write it as d squared y over dx squared. So these are first derivatives. Because it's actually written like this. What it means is the derivative of the derivative means the derivative of the derivative. It's not. But who wants to write it like that? So we write it like this. It says, oh, take the second derivative of y. So first derivative, second derivative. Is there a third derivative? Yeah. In physics, it's called the jerk. So we have position. If we talk about physics, sorry for the physics examples, we have position. Y equals f of x is our position function. Our derivative is velocity. Our derivative of that is acceleration. And the derivative of that is the jerk. What's jerk? Ever been in a car accident when you've been T-boned? You know, that sudden snapping in the other direction? That's called jerk. So if you're jump out of an airplane without a parachute, it's not the fall that kills you, it's the jerk at the end. Because your body accelerates in the other direction instantaneously. And that's what pancaking is. That's what whiplash is. When you're in a car accident and you get hit, your body was still wanting to continue in that direction, but as you rapidly decelerate and change your velocity into the other direction, it's that movement of your brain within your skull. Your skull has stopped moving, but your brain is still moving. That's what concussions are. Your skull has stopped moving, and it's going the other way, and your brain inside your skull is still moving the other way. And that's what causes the bruising in the brain, which is what a concussion is. That's airbags are supposed to slow your velocity into the, right? It's supposed to make that velocity change not as dramatic. Yeah, it's a rapid acceleration to the other direction. Yeah. Well, if you watch Star Trek, that's what they call initial dampeners. It's supposed to, as you accelerate to the speed of light inside of a ship, just expect the forces on you. So it's trying to minimize the jerk. Anyways, it's stupid, but we're just going to instantly accelerate to the speed of light. Anyways. So what this example is, you can look at it and go, wow, that's hard. But what it's really asking you to do is to tell me what the function is. Like this is the derivative. What is the function? This is the definition of the derivative statement. What is the function? What is f of x? Somebody said it quietly. X squared. And then for the next one, that's f prime of x. What's f of x? Cube root of x. Yeah. Okay, next one. Whoa, got too far. Got too far. What did I just did? Okay, so what I'm going to do is I'm going to write the definition of the derivative above it, and then you can see what I'm doing. The derivative, f prime of x, is the limit as h goes to 0 of f of x plus h minus f of x all over h. So I'm asking you what the original function f of x is. Tan x. Yep, you can just look at the second term. There it is right there. There it is. There it is. There it is. There it is. X over x squared plus 1. E to the x. 1 over x. What? Yeah. Okay. So if I asked you to find the derivative of this, not even find the derivative, do the first step. You're going to do f prime of x equals the limit as h goes to 0 of, just do the first step. Cos x plus h minus cos x all over h. Remember all those identities that we learned in Math 12 and Chapter 5 and wondered why we really had to learn them? This is why. Because we really don't need sum and difference identities for anything else other than this question right here. Lucas. I don't know. Let me check. I suspect. But I don't know. Let me look. B. Wait till the end of chapter 3. Nil. Y equals 3 to the power of x. It's the limit as h goes to 0 minus all over h. Y equals 3. This one's kind of stupid. Anybody know why this one's kind of stupid? Nobody's told me why it's kind of stupid. No, there's no x, so there's no x plus, it's just 3 minus 3 over h. You don't actually have to do it as a limit statement. If I ask you to graph y equals 3, yeah, what's its slope? 0. Like, you don't need a limit statement to do this one. Mr. F. Because you got to remember that it's f of x plus f. You need an x. There's no x up anywhere, so there's no x plus h appearing. Okay, that's enough. Let's stop here. So, you're looking at 2-4, you're looking at that practice test. Tomorrow we will continue on with the how I can graph functions, slopes, and it is a long section. Yeah, it is long. We will probably break this up into 2 unit tests, not one big unit test. For chapter 3. No. We don't have time for midterm. Don't have time. So all your marks are going to come off of assignments and chapter tests. And the AP exam if you write the AP exam. Okay? Okay, what? We could if we have time.